Hello everyone. In this lecture, we will study the linear differential equations. Okay. Before looking at how to solve a linear differential equation, we will try to know how exactly it looks like. Okay. So when we write down a differential equation of, let's say, a function y equal to f of x. Okay. It is very much usual that we will get dy by dx as it is the derivative of dependent variable with respect to independent variable. If this differential equation, whatever we get, if the maximum power of the dependent variable is 1, what do you mean by the maximum power of the dependent variable is 1? You can have y raised to 0 and y raised to 1. You should not have y square, y cube and the higher powers. No. Okay, and you should also not have the power of dependent variable and its derivatives. I mean y dy by dx, no. Y square, I mean y square is ruled out. Y d square y by dx square, no. Okay, if these things are not there in the differential equation, then it is called as a linear differential equation. So how do we define a linear differential equation? uh, I mean, look, this definition is not given in the textbook. I will give the textbook definition a bit later, but just to understand, we will define a linear differential equation now. A linear differential equation is that differential equation in which the highest power of the dependent variable is 1 and there are no products of the dependent variable and its derivatives. Okay, now after having done this, as per the textbook definition, if we have to go, textbook ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ linear differential equation ಗೆ ಅಂದ್ರೆ considering all the factors that I have explained to you just now, they have given a standard form to a linear differential equation. So to define the linear differential equation in the textbook form, linear differential equation in the textbook form, what I'll do is a differential equation of the form, a differential equation of the form dy by dx plus py, capital Py, equal to capital Q is called a linear differential equation if look, if p is some function of y, then definitely y into y would be y square. So p cannot have y. Then what can p be? P is a function of x. Okay, p can be a constant also. Constant can be a function of x. I mean x raised to 0. So p is a function of x definitely, and q is also a function of x. Okay, so therefore a linear differential equation is defined as a differential equation of the form dy by dx plus py equal to q is called linear differential equation if p and q are the functions of y, are the functions of x alone. P and q are the functions of x alone. Andre p ಮತ್ತೆ q ಅಲ್ಲಿ ಎರಡರಲ್ಲೂ y ಬರೋದೇ ಇಲ್ಲ. Okay, such a differential equation is called as a linear differential equation. So what is the standard form of a linear differential equation? It is dy by dx plus py equal to q, where p and q are the functions of x. Now, how to solve this differential equation? Look, the theory of linear differential equations, uh, at the end moment before the exam, learning that would be complicated. So what I'll do is I will just let you know how exactly you can solve the any given linear differential equation in 3 simple steps. Okay, so we will just write down how to solve it. Okay, I will just mention the working rule of how to solve a linear differential equation. Okay, I will split it into the steps. Step 1. Okay, first we will write down the given differential equation, write it in the form of dy by dx plus py equal to q. Okay, write it in the standard form. Okay, and coming to the step 2, and in the step 1 we can also say compare it with this standard form and find the values of p and q. Okay, once we have it, we will go to the step 2. Okay, in step 2 what we will do is we will find something known as the integrating factor. The theory is available in the textbook in detail. You can just go through it, or maybe I will upload it in my the upcoming videos. Okay. Okay. So the integrating factor, we have to find the integrating factor. Find the integrating factor. Integrating factor using the formula given by integrating factor is equal to e raised to the integral of p dx. Okay, once this is done, we will not evaluate anything else. We will directly write the general solution. Okay, write the general solution. Write the general solution given by you can just say y into integrating factor is equal to the integration of q into integrating factor. Since q and integrating factor both are the functions of x, q into integrating factor dx. If you want, you can write down plus c, but doesn't really matter, because after this integration also we are going to get a constant c. So therefore this is how we do it. First step, we will write down the given differential equation in the standard form, that is dy by dx plus py equal to q. In the second step, we will find the integrating factor e raised to integral p dx. In the third step, we will write down the general solution directly. Okay, so we will now see how to solve a given linear differential equation. First, we will solve one for general solution and then another one for particular solution. So we will go for an example now. Okay, so this is the example that we have. Find the general solution of the differential equation x dy by dx plus 2y equal to x square. Okay, so first thing what we have to do is we have to express it in the standard form. Okay, we will just write down the given differential equation now. We have x dy by dx plus 2y equal to x square. Okay, so this will give you, what is the standard form? Dy by dx plus py equal to q. So with dy by dx, there should not be anything that is multiplied, but here x is multiplied, so I'll divide every term by x. What will I get? Dy by dx plus, if I divide 2y by x, I will get 2 by xy equal to x square by x would be x. Okay, now it is exactly in the form of dy by dx plus capital py equal to capital q. Okay, so comparing these two, we will get therefore we will get capital P equal to 2 by x and capital Q equal to x. This is what we got. Now the first step is what we have done. We express this in the standard form and then find P and Q. Once the step 1 is done, we will go to the step 2, find the integrating factor if equal to e raised to integral p dx. So therefore integrating factor is equal to e raised to the integral of p dx. This is equal to e raised to the integral of, what is p? It is 2 by x dx. So this will give you e raised to 2 common tagare, I will get the integral of 1 by x dx, right? So this is equal to e raised to 2 times, what is the integral of 1 by x? Log x. Okay, whenever we write log x in maths, it is always to the base e, right? So this is equal to e raised to 2 log x can be written as log x square. Why? Because we have a log b equal to log b raised to a. There is a property, right? So idu, and we also have a property that is a raised to log b, the base a, e base ಮತ್ತೆ e base ಎರಡು ಸೇಮ್ ಇದ್ರೆ we can just write down b. So therefore integrating factor is equal to, we have e ಮತ್ತೆ e ಎರಡು ಸೇಮ್ ಇದೆ, e raised to log x square to the base e, so therefore integrating factor would be x square. Fine, so now we got our integrating factor. Once we are done with finding the integrating factor, we can directly go and write on the general solution. Therefore the general solution is y into integrating factor is equal to the integration of q into integrating factor dx, right? So y into, what is the integrating factor that we have now? It is x square. So y x square is equal to integration of q into integrating factor. What is q? Q is x into integrating factor is x square dx. Okay, so y into x square is equal to integration of x into x square is x cube dx. This will give us y into x square is equal to x cube. The integral would be x raised to 4 by 4 plus c. Okay, so this is the general solution. If you want to further simplify it, I will write down this as c1. So this would give me 4yx square equal to x raised to 4 plus 4c1 ಅನ್ನ c ಅಂತ ಬರೀತೀನಿ, where c is equal to 4c1. Okay, so this is the general solution. That's all. So first step, write down the given differential equation in the form of dy by dx plus py equal to q. Second step, find out the integrating factor e raised to integral p dx. Third step, write down the general solution given by y into integrating factor equal to integration of q into integrating factor dx. Okay, so this is how we can solve the given linear differential equation. Mind you, ತುಂಬಾ ಈಸಿ ಇದೆ ಅಂಡ್ 5 ಮಾರ್ಕ್ಗೆ 99% linear differential equation ಕೇಳೋದು. Okay, so we will solve one more differential equation, but not for general solution, for a particular solution. So let's go for the next question. Okay, the question says find the equation of a curve passing through the origin given that the slope of the tangent to the curve at any point x comma y is equal to the sum of the coordinates of the point. Okay, so idu kuda particular solution hai, but we will have to decode the problem. Okay, we will just read this out once again. Find the equation of a curve passing through the origin. Origin is a keyword. At origin we will have x comma y equal to 0 comma 0, right? Given that the slope of the tangent andre dy by dx, right, to the curve at any point x comma y is equal to the sum of the coordinates. What is x comma y anta kottidare? So sum of the coordinates would be x plus y. So therefore we have the differential equation. Differential equation is the slope of the tangent, that is dy by dx is equal to sum of the coordinates of the point. Sum of the coordinates of the point is x plus y. Okay, and also it is passing through the origin, so it is given that y equal to 0 when x equal to 0. So this is how we can decode the given question. Okay, now we have the differential equation with us. Okay, which is linear, of course. First we will have to write it down in the standard form as per the step 1. So this implies dy by dx plus py is what I want, so I will write down minus y equal to x. If I compare this differential equation with dy by dx plus py equal to q, okay, if there is nothing it will be minus 1 here, so therefore I'll get p equal to minus 1 and q equal to what? Q equal to x. Right, now once we have this, we have to find out the integrating factor. Integrating factor is equal to e raised to the integral of p dx, which is equal to e raised to the integral of p is minus 1 dx. The integral of 1 is of course x, so therefore e raised to minus x is our integrating factor. Once we find out the integrating factor, we can write the general solution. Therefore the general solution is y into integrating factor is equal to integration of q into integrating factor dx. Okay, so this will give me y into integrating factor is e raised to minus x equal to integration of q into, what is q? Q is x, so x into integrating factor is e raised to minus x dx. Okay, so we will have to integrate this equation. It is the product of two functions, so therefore I will integrate this by parts. Okay, using the highlight rule, as we have done in integration, using the ILATE highlight rule. Okay, first function is the algebraic x and second function is the exponential, that is e raised to minus x. Right, so what is the formula that we have? First function into integration of second function minus integration of derivative of first function. What is the derivative of x? The derivative of first function is 1 into integration of second function. Integration of e raised to minus x is minus e raised to 1. So minus into minus is plus e raised to minus x dx. Right? So this will give me just a minute. This will give me first function into, so what is the integration of e raised to minus x? Minus e raised to minus x. So minus x e raised to minus x plus, what is the integration of e raised to minus x again? It is again, just a minute, it is again minus e raised to minus x plus c. So this is nothing but our y e raised to minus x. So this is our general solution, right? uh, this implies, I will do one thing, I will just multiply, I will uh, divide every term by e raised to minus x. So I'll get y equal to minus x minus 1 plus c e raised to x. Okay, I will call this as equation 1. Equation 1 is the general solution. Now, to find out the equation of curve, or to find out the particular solution, to find the equation of the curve, we have, it is passing through the origin, right? We have x equal to 0, y equal to 0 when x equal to 0, right? So therefore what we will have, therefore equation 1 implies put y equal to 0 equal to x 0, so minus 1 plus, if x is 0, I'll get c into e raised to 0 is 1, of course. So therefore this will give me c equal to 1. Hence, therefore, the equation of the required curve is what? Y is equal to minus x minus 1 plus c e raised to x, but c is 1, so therefore it is e raised to x. So this will give you, if you want, you can just write down a y plus x plus 1 equal to e raised to x. So this is the required equation of the curve. Fine. So this is how we can solve the linear differential equation. Very important to note that you will get one question, definitely one question for 5 marks. Okay, so just make sure that you practice. We will also go through the NCERT textbook. I think we have got a few MCQs here. Yes. If I come to the 18th question, the integrating factor of the differential equation x dy. Now look, it is not in the standard form. First we will convert it into the standard form. Dy by dx, if I divide every term by x, I'll get minus 1 by xy equal to 2x. Okay, so what is the integrating factor? Integrating, this is our p, dy by dx plus py equal to q. This is our p and this is our q. For integrating factor we need only p, right? So e raised to the integral of p is minus 1 by x dx, right? So integrating factor is equal to e raised to minus integral of 1 by x is log x minus log x is log 1 by x, right? And this is to the base e. E raised to log 1 by x to the base e can be written as just 1 by x. So therefore integrating factor is 1 by x. Okay, now just erase this. Okay, the second question, that is the 19th question, if you look at what is it saying is the integrating factor of the differential equation ಇದೆ dx by dy ಇದೆ. Okay, if you have dx by dy, same working rule, ಎಲ್ಲೆಲ್ಲಿ x ಇದೆಯೋ ಅಲ್ಲಲ್ಲಿ y. Okay, so you will get the integrating factor is equal to e raised to the integral p dy. Okay, where p is a function of y. Here if I divide it, it would be 1 by y by 1 minus y square. So this is our what, the p, right? So this is equal to e raised to the integral of y by 1 minus y square dy. Okay, if I substitute 1 minus y square as t, I will just write it down. should not be so confusing for you. Okay, square. If I substitute 1 minus y square as t, I will get minus 2y dy as dt. So y dy would be minus 1 by 2 dt, right? So this will be uh, e raised to minus 1 by 2 integral y dy is dt 1 by t. So this will give you what? E raised to minus 1 by 2 log t. So which is equal to e raised to minus, if I take minus out, I mean inside, minus log x is log 1 by x, so therefore it will be 1 by 2 log of 1 by t, which is equal to e raised to log of 1 by t whole raised to 1 by 2, right? So what is to the base e, so therefore these two go off, so therefore we'll get 1 by t whole raised to 1 by 2. What is t? T is 1 minus y square, 1 minus y square whole raised to 1 by 2 is the square root, so therefore 1 by root of 1 minus y square is the integrating factor. 1 by root of 1 minus y square. I think it's option D. Okay. The finding the integrating factor can also be asked for 2 marks or for MCQs. Okay, just be prepared. That's all for this lecture. We will see the remaining things in the next lecture. Okay.